So hello everyone, thank you for spending your Saturday with me. So my session is called Interneting Your Things. I'm interested, by show of hands, raise your hand if you have worked with an Arduino or other sorts of hardware before. All right, I don't know what you're doing here then. You're probably good to go. The idea of this talk is that I meet a lot of JavaScript developers over my travels and trips, and they always seem to have a bit of a hesitation with approaching hardware. And so I like to give a little talk that's sort of an introduction to some really easy to use prototyping tools and getting to things that are really good for JavaScript developers. So if you feel that you already know a lot of hardware, feel free to leave the room. I won't be offended. So my name is Pearl, and I'm a bit of a microcontroller addict. This is only a few of the microcontrollers that I have. Luckily, I get to do this for work, so it's not just me hoarding microcontrollers, but these are just some of them that I own. And if you haven't met me before, I like to tell people that I'm a computer science dropout because I went to computer science not really thinking that this was something for me. I lasted a semester, and I dropped out and went into fine arts, which is a bit of an interesting career change. But it wasn't the type of fine arts where you look at paintings. It was actually the type of fine arts that was interactive. So I would work on projects that were called interactive installations. I actually went to school here at Ryerson in the image arts program. And I went to a program called New Media. And so I worked on art installations where the idea is that you make art for people in physical spaces. So that might require using sensors to figure out if someone has walked into a room or using touch screens. One of my early projects was I actually made this LED orb in which I had to solder 1,000 LEDs and build all my own microcontrollers. And of course, you can't really you don't get paid very well doing interactive art. So I became a web developer. But along the way, I actually realized how much I like to teach. So I would teach workshops. I used to be a bit of an Android developer, so I made this workshop where these very infamous Android figurines from Andrew Bell, there's one of them that you can it's a DIY version. So as part of a workshop, I would have people cut out holes for its eyes and put motors in its neck, and then you can control this using your Android smartphone. And it's not as creepy as it looks here. It's actually quite cute and adorable. But when it's dark, things look creepy. And so this idea of teaching led me into a field called developer relations. And luckily for me, I was able to work with one of my favorite developer relations departments of all time, which was at Google. So I worked with the Chrome team, and I would write tutorials and work on code samples for Chrome and web development things. And then today, I actually work with Intel as one of my clients, and I work specifically on hackathons, and more specifically, hardware hackathons. And another thing I do is I made this prototype a couple years ago where I'm a cyclist, and when you're cycling and you need to get from place to place that you might not be familiar with, traditional turn-by-turn navigation is not so great when you're on a bike and you have to pay attention to the road. So I built this prototype that inside of this waistband of this sort of vest type of prototype, there is actually motors. So you hook it up to your smartphone, and it will actually buzz you in the direction that you need to go. So it's all based on haptics, and you don't have to look at a screen. I made this prototype a year and so ago, and I decided, I'm going to make a company out of this. So I'm actually working on making a version of that prototype with someone else right now. So if you are a cyclist and you're interested in beta testing, I'm always looking for beta testers in the spring. And so based on my various years of working in hardware, there's sort of two truths. One is hardware is hard. And you'll hear that from a lot of people because it requires this physical aspect to it. It requires ordering things from online, plugging things in. There are occasional sparks and explosions that could happen that you don't typically get with software. So hardware is just a little bit harder. But the great thing is that hardware is becoming a lot more like software. And I'm going to show you today a few things that if you are traditionally a software developer and you're interested in getting hardware, the barriers right now to enter into hardware and to start prototyping with them are so much lower than they were even 5 years ago or even 10 years ago. And so everyone's probably quite familiar with the Arduino. The Arduino is by far the most popular microcontroller out there. And in case you're just like new to hardware, a microcontroller is essentially just a little mini computer. Typically they fit in the palm of your hand. And the one thing that they do really well is just control electricity. So there's a little onboard chip on there that you can run programs with. But the biggest thing is that it's just really good at turning on and off electricity, which means that you can use it to turn on and off lights, turn on and off motors, but then also sense the real world using sensors. So you could use temperature sensors or humidity sensors, proximity sensors. And so those are all based on listening and activating electricity. So Arduino is the most popular one. That came out in 2005. And Arduino is kind of what kicked off this sort of maker movement with hobbyists. But it's good to know that, even before that, there were quite a few, not a lot as much as today, but there were a few prototyping boards. This one was the basic stamp, and that was around 2002. But most people don't realize that microcontrollers do have a very rich history. And if you kind of go back to 1975, a company called Microchip was making something called PIC chips. But what made Arduino really popular was this idea of shields. And so when you think of software and you go online and you find a library that you like and you download it, and then you include it into your code using like a require statement or an include statement, Arduino shields are like finding those online libraries where it really abstracts functionality into this one shield. And the idea of shields is that you pop them on top of an Arduino because they all share a similar footprint. And so you can actually stack multiple shields and make like shield sandwiches. And essentially, like if you have an idea to build something, someone has probably made a shield that you could buy off the shelf and put into your project. And you don't have to know, you don't have to have an electrical engineering background to get started. You just have to figure out if someone has done the work for you. And so it's really great that this is sort of the first sort of real sort of an example of how I see software, hardware becoming a lot more like software, is just with these Arduino shields. And so Arduino was around 2005. And then I think what's really interesting that happened in 2009 was Kickstarter showed up. And Kickstarter was this great way to start crowdfunding projects and reaching an audience that didn't have to be like a gigantic mass market. But then hardware became really popular when we saw the first Pebble get it released on Kickstarter, and they raised $10 million. And this was the first major hardware crowdfunded campaign. But then also in 2012, I also saw another phenomenon happening where a lot of people who were making open source boards that weren't just Arduino started showing up on Kickstarter too. So this is an example of Makey Makey, which is sort of based on Arduino, but it's a board that got produced and got successfully funded on Kickstarter. And that was one of the first ones that I kind of saw as a crowdfunding campaign. And today, if you look at Kickstarter or Indiegogo, there's like a new microcontroller that's released like at least once a month. I can't even keep up with all of them. And it's really interesting because if you do get into hardware, Pebble raised 10 million. Not to say that they actually have 10 million in the bank, but they did raise $10 million. And Pebble actually started with a prototype, and an Arduino prototype. So this is one of the very first prototypes of Pebble, just some functionality. And then you can kind of see in the background here that that's an Arduino. So the Pebble had a very humble start. And then you look at other sort of major consumer products that have high profile, like Google Glass, and you can kind of see how it started. Like it started as a 3D printed shell with a bunch of like crazy things like strapped to it. And there's a really great interview that I have linked on these slides is Tom Chi, who worked on the design for this. He said that it only took him a day or like his team a day to actually build this prototype. So, we're getting to the point where you can quickly iterate, and everything that is kind of what you see as a consumer product typically does start off looking like this crazy contraption. And so I think hardware is really interesting because it allows you to sense the world around you. Context is king, so it gives you the ability to listen to things that software doesn't necessarily give you the ability to listen to, such as, what's the temperature in the room, or how much light is in the room, and then you can actually start creating really great experiences around what happens in the physical world. There's a phenomenon now of just putting chips in everything. There's a really funny Tumblr site called I Put a Chip in It, and it just shows all these funny examples. And they're a little bit snarky, but all these examples of like things that used to be dumb, and then they added a chip to it, and then it became smart. And hardware is great because we can actually start moving away from an experience where it's all based on screens. So, so this could be like gesture control, or just like ambient notifications. And I'm really interested in hardware simply because I'm really interested in the wearables aspect of it, of things that you wear in your body and making technology actually disappear. And so if you're new, you're probably overwhelmed because it's like, how do you choose? Because there's so many different boards. Like you have Arduino, which is a natural choice, Raspberry Pi, which was like never meant to control hardware, but people discovered that it could, and it became a really popular option. We have like really big players like Intel entering into the space. But I think what's actually really interesting is that all these like little players are coming in too. So Particle, Punch Through, and Tessel all make boards, and their teams are actually under 30 people. So I find it really interesting that you don't have to be like a giant company like Intel in order to make microcontrollers. You can actually be a team of like 10 or 20 people and actually produce a product that thousands of people use. And so when you go into a project, my best suggestion for that, if you're interested in going into hardware, kind of have an idea of what the project is that you want to do, and then start thinking, okay, what's my budget? Some boards are really expensive, and the kits can be $100 or higher, but sometimes you can find kits for, or just microcontrollers for under $10. And then you want to think, what kind of form factor do I need? Do I have space? Can it be any board? Or is it a wearable, so it needs to be really small and power efficient? And I think an important one is just what kind of connectivity do you need? Are you okay with just Ethernet? Do you want Wi-Fi or Bluetooth? Or do you even need to be connected to the internet at all? And what's really cool is that a lot of the microcontrollers now do have a huge option in terms of programming languages that you can use. Arduino, which is a simplified version of C++, is by far the most popular. But nowadays you can find a lot of microcontrollers that you can program using JavaScript or Python even. And I'm going to show a couple examples where there's actually no programming on the board at all. And I think another choice that you make nowadays is whether or not you want a dedicated environment that just runs Arduino code, or if you want a Linux-based environment. And I'm going to show you a bit of a demo using the Intel Edison, which is a Linux-based system. And it'll give you a good idea of how you want to approach hardware development based on your previous programming experience. And I think a really important one, too, is just the community. If you're stuck on a question, you don't know how to plug something in, if you can't find it on Google right away and have a really great community supporting that board, you're probably going to have a hard time. So I always like to tell people to go with a community that makes them feel invited and that they have a lot of great resources. So I'm going to give you a bit of a whirlwind of some boards, just to give you a little bit of breath. And so here's an example of a few boards that require no embedded programming. So if you're already a JavaScript programmer and you're really comfortable using web-based technologies, here's a few examples of boards that you can just use your current knowledge and just plug in boards that don't require you to do any onboard programming. One of them that's quite popular for kids is a set called Little Bits. Let me just pull up this link here. So Little Bits is all based on these little modules that you can buy, and they all snap together using magnets. Let's see if this video plays, this background. It's really weird. Like, whenever I present, this video never plays, but at home it plays all the time. But the idea is that you buy these little modules, and they come in like little individual packs. So you get like a little module for power, a module for some sort of inputs like a slider, sensor, and then perhaps like lights or sound. And they all snap together using magnets. So you can't put them in together in the wrong way at all. But it's really fun because if you can figure out what your basic inputs and outputs are, you can build like interesting shells around it and start prototyping some of your ideas without doing any programming. All of it's based on magnets, so everything's kind of pre-calibrated for you, so it's really easy to just start and play. Who's heard of a makey before? So a lot of interesting things you can do with the makey. And so the way it works is that you get this microcontroller board that looks very reminiscent of a Nintendo controller. And the idea is that you can, anything that has sort of metal or water content, you can actually, electricity passes through that. So our body is mostly water, so electricity actually does pass through us all the time. Quite a few things are based on metal. I mean, actually, this video is And so this makey is calibrated. It's based on Arduino, but it's calibrated that for even like really small bits of electricity that make a full connection, it will trigger keyboard commands. So if you already have an application that runs on your desktop, either through the browser or a native application, or even if you have a mobile app, you can just hook it up to the makey through USB or Bluetooth if you buy an adapter. But essentially, in the real world, if you hook it up to sort of detect when there is a complete circuit connection, it will trigger a keyboard command, and then your software from there can take over and do whatever you want with it. And so this is really great because on board on the microcontroller, you don't have to do any programming at all, but maybe you've already built a web application that has keyboard commands, or you can sort of edit your application to use keyboard commands. You can start immediately prototyping some of your physical world ideas with very minimal effort. I've run a lot of workshops using the makey, and I'm really surprised of what people can pull off in an hour. I did one workshop where it was a makey workshop, and someone built, a team of two built a game where it was based on like high-fiving or like sort of like clapping each other, and then like some points built up, but they did all of that using just JavaScript. So it's a really quick way to just prototype physical world things. So that's the makey. We're seeing a lot of companies. Twine is actually quite an old in terms of hardware product, but it's been out for quite a few years, and the idea is that you can go and buy a box that already has a web server sort of already connected to it. You buy this box, you take it home, it has a few sensors in it, like an accelerometer, which means that you can detect movement. I think there's a light sensor in this one, and it's just Wi-Fi enabled. So you can go and buy this box, and let's say that you have a washer and dryer downstairs in the basement, but you can't ever see it, and you can't figure out when it's done. You could put a Twine box on it, set up the web application to listen for like when it stops shaking, and then have it send you an alert to tell you that your laundry's done. So it's a really quick, easy way to start detecting things in the physical world without having to do very much programming at all. And so now we're going to move into a few things that do require programming, but they're great because they just have built-in Wi-Fi and connectivity. So by far, I would say the most popular one that I've seen is a company called Particle. They used to be called Spark. But what's really great is that they sell this microcontroller called the Photon, and it's $20, and it has Wi-Fi in it. It has a really easy to use programming environment. And so if you can imagine, like when you can start prototyping with a $20 chip, you can start adding adding internet to like everything, because why not? It's just $20. And then as you get into more production type of projects, you can go ahead and just actually buy their particle modules that have Wi-Fi in it for just $10 and start incorporating it into other projects that you might have more of a production requirement to it. But for $20, you can get a chip that you can program, and it has Wi-Fi in it. So I work with Intel, and this is not an Intel plug, but I find what's interesting that's happening recently is it used to be that when you buy a microcontroller, it used to be only based on Arduino, meaning that you write all your code in a simplified C++, and you're kind of forced to use the Arduino IDE, which if you're like a developer, it's kind of, their IDE was not very good. Like it's very basic. It's easy to get started, but when you want to do more complex things and manage more files, you reach limitations with the Arduino IDE. So what we've seen recently happen is that a lot of microcontrollers and companies are coming out with Linux-based systems. So with the Intel Edison, their compute module has built-in Wi-Fi and Bluetooth, and it runs off Linux. So it really is just like a little computer that gives you access to control electricity. The Arduino Yun, I don't actually recommend this particular board that much, but Arduino has quite a few different lines, and this particular one, the Yun, runs on Linux, but it also has built-in Wi-Fi and Ethernet, so it is a way that if you do prefer staying in the Arduino family, they do have a board that does have built-in Wi-Fi in it. If you're a JavaScript developer, Tesla is a really interesting company because their entire platform is based around being able to write JavaScript code. And so their Tesla 2 takes all that ability to write JavaScript code, but then it also gives you built-in Wi-Fi. So it's a really great platform that if you just really love JavaScript and you want to do everything in JavaScript, like the Tesla kind of has your back. What's interesting too is you can get boards with built-in 3G, meaning you're not really limited to just Wi-Fi connections. Particle has one called the Electron that isn't shipping yet, but you could have, maybe it is shipping, but I got it on a Kickstarter. But it has built-in 3G on it, and it does have a data plan that comes with it. And then another thing that's kind of coming out is that when you don't need Wi-Fi or 3G, and really what you want to do is more of like a peer-to-peer kind of connection where you're just sending very quick messages back and forth. Bluetooth Low Energy is a protocol that just lets you send really quick messages to in between devices, but in a way that's really low powered, meaning that sometimes you can buy a board and have it run off a coin cell battery, and you don't have to worry about it for 6 months. For Bluetooth Low Energy, I prefer this one from Punch Through called the Light Blue Bean, and they have another one called the Bean Plus that completed their Kickstarter about a month or two ago, so it's going to start shipping in the spring, or sorry, in the new year. And this one has like a really nice, easy to use environment. You write your code in Arduino. You can actually program it wirelessly. But the Light Blue Bean, which is this little guy here, runs on a coin cell battery. So you can start putting the Light Blue Bean into all sorts of like really small, tight spaces. And then it's really great at communicating with your smartphone apps over Bluetooth. And then when you don't need all that sort of programming power, but you just kind of want to know that something is kind of there, maybe you want to be able to enter into a room and just have a notification that says, hey, this person's in a room. There are these things called Bluetooth beacons, and Apple has kind of branded it as iBeacons, where you can buy like just tiny little boxes. They're quite small, they're postage sized, and all they do is they emit a signal saying that there is a box here, and then you write on your smartphone app or a desktop app that can detect Bluetooth to start doing behaviors based on what the signal is emitting. So It doesn't do very much, but you can do some really interesting things around like retail spaces and knowing that someone's entered into a room. Google has their sort of variation that's just based on sort of transmitting that you're in a physical space, but maybe, hey, here's a URL related to this space. So for example, if you had a physical web beacon in this room and you entered into this room, it would broadcast maybe the URL to my presentation. So that way when you entered into the room, you don't have to fumble around with looking for a URL. You just kind of enter in, it tells you, hey, here's a URL, and then you go to it. And if you like looking at the inside of beacons, I did a teardown of one that's on Medium. And then finally, if you, depending on your budget, the Raspberry Pi is actually a really great option, but it does require you to buy some add-ons. The Raspberry Pi is a Linux-based computer, so as long as something works with the USB drivers, you can get something online using just a Wi-Fi dongle or a Bluetooth dongle, and it does have Ethernet. And if you do prefer staying in an Arduino family, there are tons of shields available. This is, but there's quite a lot of crappy Wi-Fi shields, so I would recommend this one if you were like, oh, I don't want to buy a Photon for $20. I actually want to buy a $30 Arduino and a $50 shield. But you know, that's totally up to you. But this is the one that I would recommend. For getting started, Hackster.io is sort of this like DIY site where people will publish how-to tutorials, and specifically for hardware. So you can kind of go to Hackster.io. If you already have a board and you're just not wandering around, let's see. They categorize everything kind of based on the platform. So if you buy a Tesla and you're interested in see like what kind of things you can build on the Tesla, they will group together tutorials based around that. And so Hackster.io is kind of a good how-to site for that. One that's been around for quite a while is Instructables. And I do quite like Instructables for the sheer amount of content you can find. But the content, like you can find electronics projects on there, but you can also find like cooking recipes on there. So it's kind of a mixed bag of what you're going to find on Instructables. But it does win in the sheer amount of content that it does have. SparkFind is a great place to buy equipment from. And also look at their tutorials on their site, because anytime you go to a product page, they always have like a really great resource section where they will link up any sort of tutorials. They have a really big education department, so I do find that shopping on SparkFind is really great. Same with Adafruit, they're really great for you know, having tons of tutorials and especially a lot of video content. The team at Adafruit, they run weekly hangouts where you can go and see what their newest products are, chat with engineers, and people will kind of join their hangouts and do showcases. So Adafruit's really great for doing, for shopping and just having a lot of resources available for you when you're just kind of browsing around. Another company that's really interesting is Seed Studio. They're based in China. And they've really kicked up how much maker support they've been doing. And I find what's really interesting is that they started producing something called the Grove Kit, which is all based on this idea. And I have, let me see if this will work. I don't have like an Elmo projector, but what's really kind of cool is this Grove Kit. It's all based on buying this shield. So this is kind of the great thing with Arduino, as I mentioned, is that most Arduinos have a very similar footprint. So you get these pins, and everything's kind of very much the same format. So you could take this shield and put it on an Arduino or anything that's Arduino compatible. And then Grove is interesting because they made this shield that just has a bunch of connectors on it. And then they sell a bunch of modules. So like this is an LCD module. And they have, you know, the same sort of 4-pin connector. And so as long as you know how to plug like a connector into another connector, and you can't screw it up because it doesn't fit backwards, that it's really great for software programming because you don't have to worry about knowing a lot about electricity. You just have to know like what part do you want to buy. You just have to have a shield, and you just have to have wires, and you have to just know how to plug in a wire. So I really like the Grove kits in that way because they have so many components now that, like, if you do enjoy prototyping, they have so many components now that it's really easy to prototype an idea that you might have. And it's really interesting because these Grove shields, they now sell them for various microcontrollers. So not just for Arduino, like they actually have shields for the particle boards. So it's really easy to move in between systems. It's not the type of thing where I showed you Little Bits, the magnet-based one, and if you spend $200 on Little Bits, like you're just kind of stuck in their ecosystem. But at least with the Grove system, you have a little bit of ability to move around and choose different boards or choose different components. And then if you're Toronto-based, which I'm guessing most of you are, I maintain this site called Where to Buy Electronics in Toronto. And I try to keep track of all the places that you can go in Toronto and buy things. And I will just actually pull up. And it's just like wheretobuy.klab.ca. And if you somehow have this urgent need to go and buy electronics today, my favorite place is this place called Creatron at College in Spadina, more like College in Augusta. And they have they have a huge selection of things. Depending on the day, the staff is friendly or not. But everything's kind of organized in like these little baggies, and everything's like very clearly marked. So I find the shopping experience there pretty good. So let me see how much time I have. A few minutes. So I want to show an example of just using the Intel Edison. I'm really obsessed with time and how I just have an inability to make appointments, and I'm just late all the time. So I decided that as a demo project, I would make a smart clock using Node and the Intel Edison. And the idea is that the Intel Edison, here's the compute module. The idea is that it would go and ping my Google Calendar and say, hey, is there a meeting coming up? And if there is, it would update the LCD screen and say, 15 minutes into your meeting. And then it would do a countdown. And the closer it got to my meeting, the more red the screen would turn. So that way it's just something that kind of sits on my desk. And it just ambitantly kind of prompts me that maybe I should get going. And obviously, it's something where you can start adding tons of features to it because it's just something that you program. But it's really nice that the Intel Edison has built-in Wi-Fi, so it makes getting the Google Calendar API calls, it makes the calls really simple. And so here's a bunch of specs on what the Intel Edison is, but I'm like, this is super boring. I've been working there for long enough that I actually still don't remember what all the specs are, which is really bad because people ask me all the time. But really, I'm more concerned of what can you actually do with the hardware. And unless you're making a production product, most of the time, most of these specs don't matter at all. But the most important thing is that it is a Linux-based computer that can control electricity. With the Intel Edison, you can get all these kind of breakout boards. So there's one that looks like an Arduino, and here's the little compute module there. You can get a little smaller breakout board, but you have to, when you do want to make your connections, you have to solder everything to this little breakout board. Seed Studio makes these interesting kits called the Shadow Kit, but spelt with an X, where the Intel Edison fits on this little board. There's a programmer, but then when you don't need to be programming it, you just take your parts, take the parts off, and then you get something really, really small that could be good for wearables. Let's see. So when you get a brand new Edison, there's a couple things you kind of do. Is you install the compute module, you plug in your cables. If you're on Windows, you have to install USB drivers. And what's kind of cool with the Intel Edison is that you can actually shell into it using either SSH or serial connection, and you can start controlling it exactly like you would a remote computer. So I find that super interesting. It's got built-in Wi-Fi, so you get your board online using a couple commands. And then if you want, you can install an IDE. Intel has something called the XDK that is good for Node JavaScript development. If you're more of a C++ person, you can use sort of an Eclipse environment. But really, if you wanted to, because it is a Linux-based system and you're one of these, someone who like really loves VI, you can actually just shell into it and write all of your code right on it. Let's see, how much time do I have? Okay. You can kind of see the size comparison here where the Intel Edison module is super tiny. If you are interested, I do have one here with me. And you just kind of like plug it into your breakout board. You press it in, and then there's a couple screws to attach it. But that's kind of about it. That's about it in terms of installing the module. It has 2 USB ports that you can use that are available. One is for powering it and putting USB. So there's like this little switch that you switch, and then you go and you plug in your cable, USB cable to it, and then you plug it into your computer, and then it powers up. And then if you're on Windows, then, there's some drivers you have to install. And when you're doing Arduino development too, you typically install what's called FTDI drivers. So it's not just for Windows, just particularly with the Edison, you do need these FTDI drivers. But when you do start with Arduino development, keep that in mind, like FTDI, because that's where everyone kind of gets stuck. So it's very straightforward though, because most of it's just like a WYSIWYG installer. The Intel Edison does also have some other USB drivers that come with it, and that's pretty simple too, because it's just a just a WYSIWYG type of click next sort of setup. And then when you want to start communicating with the board using a serial connection, I pointed out that there's 2 microcontroller ports. Top one's for power, the bottom one's for a serial connection. And that one's pretty straightforward too. You just plug in a micro USB, and then you plug it into your computer. If you're on Windows, putty is what you would kind of use to make that serial connection. You plug in a COM port, you tell it that's a serial connection, and then you give it a baud rate. And then you just kind of connect to it. You can log into it. And at this point, it's kind of cool because you're actually in your Intel Edison the same way that you are with a remote computer. So you can run any sort of command that you might run as a Linux command once you're logged in. Let's see. I don't have my Edison hooked up now, but Mac, I was going to do this live, but Mac is the same where you just figure out, what port is your Intel Edison on. Screen is a program that's already built in to do serial connections. So you just type screen, you plug in what port you need to connect to, you give it a baud rate, and then you're like logged in. So you just have to like log in with your like a root user, and then you're in there and you can start running Linux commands. Getting the board online is also pretty simple too, where there's this one command called configure_edison-Wi-Fi. And it'll give you a little bit of a scene where you can go scan the Wi-Fi, you choose what connection you want to connect to, you plug in that number, put in your username credentials, and then your board is online. And so it's kind of cool. My Edison is not online right now, but I think my screen for this still is available. The Edison will have an IP address that it will broadcast. So it's kind of cool because you can just kind of double check that it's online by visiting the IP address. And this is really good to keep in mind too, because if you are, if you prefer making web servers, you can build a web server, put it on an Intel Edison or any sort of Linux-based system, and know that you have a computer that can control electricity but you have a web server that you can write for it. So I don't know, you can make some really interesting things there, say use Node and use an Express server, and then you could use your smartphone and go to the IP address of the Intel Edison and start running commands like using maybe like URL parameters like turn on equals true or something like that. And then your node code can kind of figure out what it needs to do from there. So that's a really great way to start. If you are like a web developer or especially a node developer, this is kind of like the easiest way that you can start thinking about connecting a microcontroller to smartphones or other things that are around you. Let's see. And so I said it's optional to install an IDE. This is what the Intel XDK looks like. If you've ever used brackets, it's more or less built on brackets. But the nice thing with XDK is it just gives you these buttons along the bottom. It allows you to write your code on your desktop and click a button in order to upload it to the Intel Edison. And then some buttons to run and stop your application remotely. Let's see. I think I have 15 more minutes, so let's see what I can do with this. Okay. So going back to the smart desktop app that I did, the really nice thing I think with using a Linux-based system, especially one that can run Node off the bat, is that you can prototype. You can prototype your application on your desktop. And so for this particular smart desk clock that I made, the first step was just going through the tutorial on the Google developer site for their Google Calendar API. They have a Node example on there. And so they'll step you through creating, enabling the Calendar API, getting a secret, your authentications. You install 2 Node libraries. You copy their sample code and run it on your desktop. And then there's this one step where you just have to visit a URL in order to get a token. And then you plug it back into your desktop app, and it then makes a connection to your Google Calendar. And so I did record this screencast, but this, and I think they actually just updated the Google developer site recently, so it won't look exactly like this, but it's pretty straightforward because they give you all the code for this demo, right in their app. So you kind of just follow the steps to create the Calendar API. It's more or less an exercise in copying and pasting, really. Copy and paste, and then you run it. And I actually have, I think I still have it up on here. Let's see. So I do have the quick start on here. So you can kind of just, after going through this process of copying and pasting and clicking on things, you can run it, and it will go and see what my next event is. And my next event apparently is the after party tonight. But I do have other important things that I do in my life. But so I have this calendar that it's hooked up to. So let me just push this down to a little bit later. So I just moved that calendar event down. So if I do run it again, I should see that, full stack TO. So here I'm just prototyping on my desktop a Node application. But in the end, I actually want to move this on to the Intel Edison. And so what's kind of really cool is that it was quite easy to take something that I wrote on my desktop, import it into the XDK. I have to create a package.json just so I can tell the Intel Edison what dependencies it needs. And then I can run the Node app using the command line. I can shell into it, write node space quickstart.js and just run it. And there was only one tweak that I had to do, and that was just around the file path references. And it was more or less the exact same process as prototyping on my desktop. And I don't know if this video is actually that interesting. Let's see. Yeah, so I'll just scrub through this really quickly, but I imported the project into the XDK. It was the exact same code. I have the code up on GitHub if you are interested in just having a look at it. You know, it's the exact same code, and you can't see the text on here, but I did just change literally 2 lines of code on here. Like here I'm changing like 2 lines of code. Whoops. But essentially, I was able to write something on desktop and port it to the Intel Edison with very minimal effort because the Intel Edison runs Linux. So that's a really great platform to think about if you are a node developer. And then from there, the next aspect is just plugging in, you know, what kind of electronics components do you want to use. For the smart desk clock, it was just a screen that I wanted. So the Grove kit has an LCD screen, and as I showed you before, as long as you can plug in a wire to another wire, and you can figure out which wire to plug into which little slot on the shield, that's as much hardware as you need to do. Intel has a few libraries that make talking to your GPIO pins a lot easier. And so when I say GPIO, it's just the pins that kind of stick out of the board that allow you to talk to electricity. MRAW is another library that's like the low-level library, just to say, hey, electricity turn on, or this pin turn on, this pin turn off. So it's super low level, but it's a library that sits on a Linux operating system. And then they have another collection of libraries called UPM, which when you have a board, or when you have a component that's slightly more complex than just like, say an LED, you just turn it on and you turn it off. It's not very complex. That you can kind of just do with MRAW. But when you have something more complex, like an LCD screen, there's a lot more that goes into it. So Intel has made a library called UPM that just is a collection of, when you want to use an LCD screen, there's sort of a helper library for it. If you want to use a more complex sensor, like let's say a humidity sensor, you can use the UPM library for that. And so all those examples are kind of on GitHub and on Intel's site. So there's a few, you can't actually see any of that, but it kind of looks like this, where MRAW, you just include the MRAW library. These are node examples. You tell it what pin that you want to turn on and off. You tell it if it's going to be an input or an output. In this case, it's an input. So then you can use, you know, .read or .write in order to control it. And then the higher level libraries are very similar, where you just include a library related to that component. You make a new instance of it. You tell it what pin you need to talk to. And then it has like a fairly easy to use, like a human readable API to start communicating with your components. And so for the smartwatch, smart clock application, you know, the desktop application, when I ported it over to the Edison application, you know, I barely had to make any tweaks to it. All I have to do is, you know, add some information around using the LCD screen. And so this is kind of the bare minimum that you can kind of add to your application to get an LCD screen saying hello. And then really the rest of it is just, you know, JavaScript. So, you know, I wrote some helper libraries to make the LCD screen scroll. But in general, like I didn't really talk about hardware for that long, right? I talked mostly around writing a node application and adding it in a library in order to talk to your hardware. But really all of this is not hardware related at all. It's just node, it's just JavaScript. And so kind of in closing, as a reminder, hardware is hard. There's a lot of extra little complexity around ordering parts. But hardware is a lot more like software nowadays. So if you ever felt hesitant to start getting into hardware because you're just like, oh, I'm just kind of a software person, I don't know if do I have to go to school? Do I need to get an electrical engineering background before I get started? And it's like, no, it's like as long as you can plug one wire into another, you're good to go to start prototyping. So I do encourage you that if you are interested in hardware and you have some questions for me, I don't have time for Q&A right now, but I will be around for the rest of today. I'll be in and out, and then for tomorrow too. So feel free to come find me, or you can just hit me up on Twitter. I'm just @PearlChen. I try to answer my Twitter questions, not always, so just make sure it's engaging and I want to answer your questions. But I am definitely open to talking about hardware at any point, so feel free to ping me. So thank you so much for coming to my talk today, and enjoy the rest of your day.